All right, this is the Algebra 2 Lesson 5 video over logarithmic functions. So logarithmic functions are the inverse of exponential functions. So I'm going to kind of illustrate what I mean by that really briefly. We learned about our exponential functions. Exponential functions might say something like this: 3 squared equals 9. This is an example of an exponential expression. Well, a logarithmic expression turns this around. This says that 3 squared equals 9. If I were to express that as a logarithm, I would express it as the log base 9. Sorry about that. The log base 3 of 9 equals 2. So let's talk about how these things map onto one another. So you can see here that originally, when we first learned about exponents, we learned that this is what we call the base. This is what we call the power, or the exponent. And then, of course, we have what you might say is the answer, right, to that problem. The base 3, power 2, and the answer is 9. So in my logarithm, and I read it this way when I said it, the base number, it goes kind of below the line, sort of, after you write log. So this is still the base. So we say log base 3 of 9. That's the way you'd read this. Log base 3 of 9 is equal to 2. So you can see what's happening is I'm actually looking for, when I do the logarithm, I'm actually looking for the exponent. So it's, in a sense, if I didn't have this 2 here, and I said, what is the log base 3 of 9? I'm asking the question, 3 to what power gives me 9? And we know the answer is 2. 3 to what power gives me 9? And the answer there is going to be 2. So this is what logarithms are. They're the inverse of exponential functions. So they take us through some basic terminology. One major thing to say is that on any calculator that you work with, the logarithm button is going to be, go here, the log that you see on this calculator is a log base 10. So if I do log of 100, for instance, the answer is 2, because 10 squared equals 100. So that's why you can't just type log and expect it to know what the base is, because the calculator only does base 10 logarithms. So when you type this logarithm here into the calculator, you need to realize that it's log base 10 of 100, which of course the answer is 2, because 10 squared equals 100. And that's how we get that. All right, so that's one other kind of key component to what we're doing here in this lesson. One other major thing that they do is they want you to understand something about the reciprocal relationship of logarithms. So I'm going to use this example here on the screen to illustrate this. What this is doing is it's asking for a log base 2 of these numbers. So in other words, the question that's being asked here is the following: 2 to what power gives me 1? And then 2 to what power gives me 2? See, that's what's happening here and there. Let me make this a little bit easier to read here. That's what's happening here. That's what's happening here. And so we know that 2 to the 0 power gives me 1. And so that's why the answer over here is 0. And we know that 2 to the first power, or to the power of 1, gives me 2. So that's how we know the answer there is 1. And then it keeps going. So if I kept going, it'd be 2 to what power gives me 4? Well, that's going to be what we see right here. Well, 2 to the second power, or 2 squared, gives me 4. That's where that answer comes from. And then they do something interesting here. Now suddenly we see that we have 1 over 2, or 1/2, and then 1 over 4, or 1/4. Now, they're not necessarily expecting us to just know off the top of our head what the power is to get those numbers, but there's a key property here that's coming into play. And that is that when you already know the logarithm, like we know the logarithm of 2 is 1, I'm talking here about this line right here. When I already know this information right here, I know that if I do 1 over 2, 1 over that number, the logarithm is going to be the negative of that answer. So if the logarithm of 2 was 1, then I can conclude that the logarithm of 1 over 2 is negative 1. And then using another color, if I look at the line with 4 and I say, okay, well, the log of 4 was 2, then I can conclude that the log of 1 over 4 is negative 2. And that's where that comes from. So this idea here is like once you get the positive answers, you can do any of the reciprocals really easily by just doing the negative answer. And so let's look at how this actually plays out in the lesson, because that's kind of the main concept that you're dealing with in this lesson. So going down, they ask us a few questions. The number y, remember that's the exponent of that expression, because the b is the base, the y is the exponent. The base of the logarithm cannot be equal to, this is described up here in the, let's find it right here. Somewhere I'll kind of help you find it here. Yes. The logarithm base cannot be 0, somewhere in there. Cannot be equal to 1. So it cannot, the base of a logarithm cannot be equal to 1, and it must be positive. So you can't have negative logarithms. And when we're talking about logarithms there, when we talk about the base, we're talking about the number here, the base here. This must be positive and cannot equal 1. Okay? That's kind of a key concept there. And then let's go ahead and summarize what I went over in our example earlier. If we know that the log base 2 of 4 is equal to 2, then we know the log base 2 of 1 over 4 is equal to negative 2. So reciprocal logarithms give us negative answer. That's what that's kind of summarizing. We'll see more of that in the actual lesson. All right. Then we go to see number 3, the greater the base, the closer the graph is to blank when x is greater than 1. That's going to be described right here in the lesson. So you can just read that right there. That's right below the graph. Then we get number 4. Okay, so this is where we do the reciprocals. And there's actually a typo here. This should read this way. In other words, this expression is the reciprocal of this. So it's the reciprocal of that expression. So we know that when we have the reciprocal of a logarithm, we have the negative answer. So if the original answer was 2.09079, then we know we need to find the negative version of that. And the rest of this is more or less using that concept. Again, this is a typo. This should read log b of 3 over 4. Again, it's a reciprocal. So then you're looking for the negative answer. And then here it does it in like a generic sense. If the logarithm of p is q, and then I get the negative q as my answer, what should go in the space for the number where p is there? Well, it's going to be the reciprocal of p. All right, now we have a table. Now the table is not really drawn in very well, so let me just kind of show you what it's doing here. It's doing like I did in the example above. Sorry, it's not so great for me to draw, but let me explain. So it says complete the table. You have a value for x, and then you have to find the logarithm. In other words, for each one of these, you need to do the following. It's asking the question, 3 raised to what power gives me 1? 3 raised to what power gives me 3? 3 raised to what power gives me 9? And then it goes and it does reciprocals. Reciprocals of the ones above. So then you do the negative rule for the reciprocal of those logarithms. So that's how you fill in this table. And then looking at the next one, similar idea, just the reverse. So now you're looking for the x. And so you're actually, this is a lot easier. The logarithm, the log base 4 of x is 0, which means that 4 to the 0 power equals, and that's what goes in that blank. And then 4 to the first power equals, and that's what goes in that blank. 4 squared, and so on. 4 to the negative 1, 4 to the negative 2. And so you fill in the answers for x for each one of those. That's pretty much it for that. With these, we know that the bigger the number, the bigger the base number is, the closer to the x-axis it is, the more flat it is. So the 8 is going to be the flattest, then the 3, then the 2. So use that to answer that question. It's the reciprocal, it's the inverse of your exponential functions. The rest of this, you could solve these using various methods. This is review stuff. Find the solutions. That's the intersection point of these two lines. Remember, this is quadratic, so you find the points where it crosses the x-axis. And then simplify this. That's from the last unit, so hopefully that's pretty fresh in your mind. Okay, and I think I covered most of the material from lesson 6. So let's just check that out to make sure. No. All right, well, we'll come back with a video for this, and then we will keep going.